This is Java OCA Unit 2 Lecture 3, and in this lecture we will be discussing the Java reference variables. Topics in this lecture include what reference values are, what defines object equality, and the topic of aliases. Reference types are variables declared as an instance of a class, and that class can be defined either by the Java library or by a programmer. A reference variable stores what we will call a pointer to the location in memory where the object resides. The memory address location is where the object's data is stored. When we say the object's data, we're talking about the instance variables or the attributes. The default value for a reference type is null, meaning that there has been no memory reserved for this object and that copies of the instance variables don't yet exist for this object. Over here on the right, I have an image of a declaration of a person object. So there's the declaration type. The identifier is Hugh Grant, so that's the variable name. We are using the new keyword, which is telling the JVM to allocate memory and make copies of the instance variables, and we're going to follow the instructions given by the person constructor on how to initialize the attributes for this object. I have a graphic down below here, and this is just to simulate a memory chip, a RAM chip, and here is a hex address in memory, and that is what's stored by the reference variable. Reference variables store a pointer or a value that is unique to the object that you've just declared so that it can come to the memory location and say, these are the variables and the values that they're storing, which we will call the state of the object. So the object class is the superclass of all Java classes. That means that every class is either directly or indirectly a descendant of the object class. If you define a class and you have no constructor, then the object class constructor will step in and instantiate by initializing your attributes to their default values as defined by the Java operating system. Classes will also inherit a list of methods from the object class. Two of those methods that we will focus on are the toString method and the equals method. So the object class toString method establishes a way to print our class objects, and the default definition will print out the fully qualified class name, followed by the @ symbol, then followed by a hexadecimal representation of the object's unique identifier, or what we are calling the pointer. So you can see up here in BlueJ, I've imported the ArrayList class, and in the ArrayList that I've instantiated, I'm using an object type, and then after that, I instantiated an object type object, which I put in the ArrayList and then later printed out. And when we printed it out, this is the output that we got. And we see that java.lang.object is the fully qualified name for the object class. Then we have the @ symbol followed by a hexadecimal address. And really, I keep calling this the pointer. It's not really a pointer. This is really just a hexadecimal representation of the hash code. Now, we don't really need to get into the hash code for the Java OCA exam, but you'll see me make references to it here and there just because that is the unique identifier. The Java virtual machine, the JVM, uses hash code to uniquely identify objects, and it is converted to a hex value, so it looks like a pointer address when it gets printed out. So now we have the object class equals method, and the equals method as defined by the object class simply checks if the reference variables are storing the same value. That means they're just comparing memory locations or pointers. So the object class version of equals method is the same thing as using the double equal sign, no different. The object class version of equals method will only return true if the objects have the same memory location. So we must overwrite the equals method because there are other ways to define two objects as being equal without being one and the same. So again, on the right side of the slide, I have a graphic. This is the code that I wrote in BlueJ. This is the output. And you'll see that I have a printout just to say we're looking at the object class equals method, and it returns false, false, then true. And if you look up here, those lines false, false, and true are using ob1.equals ob2. And then ob2.equals ob3, and then ob3.equals ob1. And we see that it came out true for the last one because here, look at how ob3 was initialized. It says, declare an object called ob3 and set it equal to ob1. This means that you're just having it store the same pointer. So if we're just storing the same pointer, they are what we call aliases. And that's what an alias is. An alias is when you have two different variable names that store the same pointer. And a very common way to think of this is Bruce Wayne and Batman. They're the same person, they go by two different names, but it's the same DNA underneath. Now, if we come down to the second output title, it says comparing reference variables with the double equal sign, and you see it has ob1 double equals ob2, ob2 double equals ob3, and ob3 double equals ob1. And we see the output is false, false, true, the same thing we got from the equals method. So the equals method is exactly the same as using double equal signs until you override the method. So one of the first classes that we get introduced to that overrides some of these methods is the string class. And the string class toString method prints out the list of all of the characters that are stored by the string object. And if the string class did not do this, the output would look like this instead. We would have the fully qualified name, java.lang.string, followed by the @ symbol, followed by a hex address representing that string object. So just as the string class overwrites the toString method, so will we need to do that when we define our own class types so that we have a meaningful output, so that we can track the state of our objects perhaps to see how they're changing during runtime, or for whatever purpose we see fit to define our toString method. And here's a look at the equals method as defined by the string class. It overrides this method also. And the string class version of the equals method is going to compare the list of characters stored by the string object, not the memory pointer. And this makes sense. If we want to know if two strings are equal, we want to know if they have exactly the same letters arranged in exactly the same way, using the same capitalization and all. So when comparing the two objects with the equals method, it will give us true if they have the same list of characters and not rely solely on the memory address. So now, when you use double equal signs with string objects, that's if you're testing, if you're looking at aliases to see if they have the same pointer. And if you want to know if they have the same contents, you use the dot equals method. So we will have to overwrite this method as well as the toString method for our classes so that equals has a meaningful representation to us. And you can look here on the graphic on the right. String 1, I stored hello in between double quotes with a capital H. String 2, I did the same thing. And string 3, I did the same thing. So notice that we have different ways of constructing a string, and that when I use the new, something different is going to happen here. Let's look at this. So my next lines of code say to print the identity hash code for each of these, string 1, string 2, and string 3. The identity hash code is what is being used as the pointer. So if we look at string 1 and string 2 in the output window down below here, they have exactly the same identity hash code. And you might say, well, why is this? Java tries to be efficient with its memory management. And when string 1 was set equal to hello, and then string 2 was using the same thing, the JVM said, oh, I already have a string storing the characters of hello in exactly the same way. I'm going to set it to the same pointer value as string 1. And then string 3, we use that new keyword, which says, I don't care if hello is stored someplace, you are going to allocate new memory and store hello at a new memory location. So by using the word new, you force the allocation of new memory location and store those characters for hello there. And now we see why string 3 has a different identity hash code. So then the next 3 lines of output just say string 1 is storing hello, string 2 is storing hello, string 3 is storing hello. When we use the equals method, we expect them all to return true, and they do. But when we use the double equal sign, we only expect string 1 equal to string 2 to return true, because they had the same identity hash code up there. But string 3 will return false because the new word was used to allocate a new memory location, and which is why those memory locations will not produce a true output, but rather a false output. So we keep talking about the state of an object, and the state of an object is defined as the current value stored by an object's attributes. And here I have just simulated 3 dog objects, D1, D2, and D3. They're all dog objects. And you can see that they're using a default constructor. And after they're constructed, we used a setter method to set the name for dog 1 as Rex with an age of 3 and to set neutered as false. And then we went with dog 2. We set the name to Fido, age 5, also neutered as false. And then dog 3 was Rex, age 3, and neutered was false again. We expect these two, since they have the same state, their attributes are storing the same values, to produce a true output when we use the equals method. So when we define our equals method, we might want to say if the name, the age, and the neutered status are all equal, return true, otherwise return false. However, just because 2 objects are equal at one point doesn't mean they can't change later. So if we were to take that dog in D3 and get that dog neutered, but dog 1 was not neutered, then one would be true for neutered, one would be false, and that would change the equals return value to be false. So an object state can change during runtime. At times, 2 objects may be equal, but at other times they may not be, as the attributes and the values they store change. So here are a list of some Java reference types that you should be familiar with. You should know the string class, the random class. This is different from the math.random method. This is a class dedicated to generating random values. The scanner class for getting input from users through the keyboard. You should know how to use arrays and array lists. And these are all reference types because arrays store a memory address. They're going to give us the default Java toString output with a fully qualified class followed by an address. However, the array list class would have a better defined toString method that gives you the elements stored by the array list. Examining the arrays and the array list class is a good example of saying what we don't want from the default values of an array class and how we should override it to get the outputs that the array list class provides. Also, for Java reference types that you should be familiar with are all of the wrapper class types. Wrapper classes are an object type that is used to put primitive values in, and these are useful for classes that work strictly with objects, such as the ArrayList class. This is the one that we will see and use the most. There's the list interface, which also relies on strictly objects, so we need the wrapper classes for, and there are others in the Java library that work in such ways, or you might define your own class that relies on objects. So you can see here that integer is the wrapper class being used for the array list so that it can work with int types. Now, since Java 8, the wrapper classes have been doing what's called auto boxing and auto unboxing, so you don't have to do any of the intermediate steps to convert from a primitive int to an object or reference type integer. That is all done automatically for us. And then, of course, the coolest thing or the coolest feature of object-oriented programming is that you can define your own class types. And whether it's an animal class or an instrument class or a car class, or if you're making creepers or zombies or endermen for your video game, whatever you need to define, you can set the attributes through the instance variables, you can set the behaviors through the class methods, and you would have to override the inherited methods such as equals and toString so that they give meaning to the class that you defined for the purposes you need. So this is the end of this lecture. So you can go on, complete your assignments, email me with any questions.